Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So hello everyone. So today I'm going to talk about our project is mining query click logs for the collaborative search. So my advisor is Professor Chengxiang Zhai, but unfortunately he is not here right now. So I'm Xiaohong Wang. I'm going to present our project. So talk about collaborative search. So what does collaborative search means? By collaborative, people always think that how could we help one particular user by the other users. So by the collaborative search, we mean how could we improve the search result for a particular user by exploring the information of other users. Okay, so what's motivate our collaborative search? So there may be a lot of reasons why we want to do the collaborative search. We see two particular reasons. One is from the personalized search. So for the personalized search has attracted a lot of attention recently, but however, personalized search has one limit is that an individual's information is always limited. So if you just rely on the information about one person, one individual, so it's you have to reach some limit there. So the idea of collaborative search is how could we utilize the information about other users to help a particular user. So this is one motivation for our work. The other one is for the difficult topics. For people always find people are not expert in every field. So in some field you want to find some useful information. It's not that always you can come up with good queries. But for the particular information need, maybe other users have similar this kind of information need, and they are expert in that field. So by the collaborative search, we want to utilize some kind of search expertise of other person to help you. For example, how could we reformulate an effective query if the current user thinks that his query is not as effective as he thought? Okay, so actually, we have a UCare project, and its starting point is to do client-side personalization. Actually, our collaborative search is motivated from this project too. So in this project, so we want to do some kind of personalization in the client side. So in every day, people have interact with a lot of search engines. For example, web search engine, desktop file, and emails. There are a lot of histories. So what's the web page this user viewed, and what's the query history about this user? So the goal of this project is to learn or build a personalized search engine for each individual. And this personalized search engine could utilize all the history of this user and then to do the personalized to personalize its search result. For example, Java may mean different things for different people. If we have this kind of history information, we can personalize the search result such that to satisfy or to help the user better. So if we build for every individual, we can build such kind of personalized search engine. So there's maybe a lot of search engines. So the next step is how could this search engine help each other? Okay. In general, here is our vision. The first step is we want to do the client-side personalization. So this basically to integrate all the information of a particular user to build some personalized search engine. Next step is how could we collaborate? Since this kind of information is kind of limited, the next step is how could we collaborate many personalized search engines to do collaborative search. And the last thing is some kind of ambiguous. We want to go beyond this search to support the user task. So this is the general vision. So along this line, we have done several works. The first work, most of the work focuses on the personalized search. For example, we have developed a theoretical framework and a toolbar for the personalized search. We also did explore the user's search history to do some implicit feedback to improve the retrieval performance. Recently, we also did some explicit feedback. For example, give a query, we actively provide some documents or provide some terms to let user judge whether this document or this term is relevant to you. And we use this kind of information to improve the personalized search result. So the next stage we are going to do is to do the collaborative search and the task sort. So I'm going to talk about collaborative search in the following slides. Okay, so in the next slides, I'm going to talk about how could we do the collaborative search by mining this kind of query and query click logs. So the basic idea here is that we want to learn the user's preference from a search log, and then use this preference to customize the search result, or we could infer what a future user would like based on the history of other users. So we do not expect this kind of technique to help every type of query, but we do expect our techniques, our collaborative search, to help those kind of difficult query in the case that you cannot find any relevant documents in the top ranked list. Okay, so there may be a lot of different research topics. So we are particularly looking into two research topics here. The first one is how could we organize the search result more meaningful from a user's perspective. The other thing is how could we reformulate a query if a user finds that the current query is not effective. Okay, I'm going to talk this two directions in the following slides. So the first one is learning from the web search result to organize web logs to organize search results. This paper will be published in the CGIAR 2007. Okay, talk about result presentation. The most common or most normal one is just a ranked list. So here I just give you an example to show this one. So this kind of result representation is good for some kind of navigational query or some non-ambiguous query. But is it best for everything? How about the ambiguous query or some kind of difficult query? So for the ambiguous query, I give you an example here. Jaguar, it may mean a car, or it may mean the animal. If you put the result in a ranked list, so this list is kind of mixed of these two topics. So this, if a user particularly interested in one aspect, so this kind of ranked list is not good. The other one is difficult queries. For difficult queries, we mean that all the top ranked results are just non-relevant. If you give a query, and if you want to find the first relevant result, you have to go through this list one by one until you reach the very first one. So obviously, a ranked list is not as effective, is not good enough. So as an alternative, people have thinking about how could we organize this search result. One most common one is to cluster the search result. The basic idea here is that okay, you give me a list of ranked results, then I partition this result into different groups. With each group is kind of a coherent topic there, and then we have to generate some labels to indicate what's the content of each cluster. So here in the left side is kind of the class label generated. And then when people doing the search, it can look at this kind of class labels and then to decide which one is relevant to his information need. Once he feel some of the class is relevant, it can click on one of these labels, and then the result will be changed to just show the result in this cluster. Okay, so the current method for clustering search result is totally based on the content of the snippet or content of the documents. It do some clustering algorithm on this side and then generate some labels from the content of the snippet or content of the search result. So it's totally based on the search result. So what's the problem with this kind of approach? So we see two kind of problems. The first one is the partition of a search result. So for those kind of clustering to be effective, this kind of search result the partition of search results to be meaningful to a user. So whether the clustering based on content is meaningful to the user or not. So for example, for a query every code, we could partition the result in along this line, whether the page is about phone calls or whether the page is about zip code. We can also partition the result into whether the page is about the international code or whether the page is about local code. So these two type of partition seem equally meaningful, but which one user prefer? So this is the first problem about the partition of search result. The other thing is about class labels. We have shown you that the class label is very important for the cluster algorithm to be effective. So this class label should be meaningful and informative enough for the people to do to make a good decision. So I just show you an example here. For example, this is the class label generated by the current clustering algorithms. This is kind of this phrase is extracted from the search result, the content of the search result. So by looking at this term, I cannot figure out what does this cluster means. So this means that if you label the cluster from the content of the search result, it may not be informative enough or may not be meaningful enough for a user to understand that. So, okay, so this is to illustrate the two problems about the current method. So our idea is that we're going to solve both problems through mining the click logs and query logs and click logs. Okay, so for the first part, we do not just rely on the content to learn the partition. We use we impose a user-oriented partition of the search result. How could we do that? So given query, we do not just look at the search result. Instead, we take a look at what the search result tells us, search log tells us. So this search log is kind of the history which records the interaction of the user with the search engine. It basically represents what the user need, and what's the user interest there. So we give a query, we find some information from these logs. These logs basically tells us what the user is interested in given this query. The second thing is that we learn aspects from this search logs. We partition the information in the search logs into different aspects. These aspects represent what the user interest given this query. And finally, we just put the result, categorize the result into these learned aspects. So this is the first part. We impose a user-oriented partition of the search result. The second part is user-oriented labeling. So class label is very important. So to be informative, we do not rely on the content of the search result to label cluster. Instead, we use the past queries. So use the past query as the label of a cluster. So past query is entered by the user. It's obviously it's more accessible or more informative from a user's perspective. Okay, in a word, we just our motivation is that we will going to organize the search result in a user-oriented way. Oh, here is an illustrator about our approach. The basic idea, for example, if you give a word car, if the people input a query car, so what we do, the first thing is to find the related past queries from the logs. For example, we can find this kind of queries which are very related to the query car. So these queries are the past related query to the user input. Next step is we learn the aspects by the clustering. For example, all the queries which has been related, all the related past queries could be clustered into several aspects. For example, the first one, it may be the car rental. The second one is about car pricing and use the car and so on. And after we do this kind of clustering, the third step is just to categorize the search result into these different aspects. For example, the first two URLs, Avis and his is more about the car rental, and we put it into the first aspect. And second one is about used cars. I will put into the cars.com is about the car pricing or used cars, and we put into the second aspect. Okay, here is just the overview about our approach. Let me talk a little bit more about our implementation. So for the implementation, we have 3 steps. The first step is to find the related past queries. To find this past queries, we first build a history collection from the search log. I will give you more details about this history collection in the next slides. And in this collection, each past query is entry in this collection, and it corresponding to a pseudo documents. So I will go into talk how could we build this pseudo document based on the search logs. So after we have this history collection, it's very easy for us to find the past related query. We just use the ocopy method to retrieve, to do a retrieval on the history collection. We can get a list of the related queries. The second step is to learn aspects by clustering. What we do is just we use a star clustering algorithm on the top related past quality retrieved in the first step. And this star clustering will output a star-shaped cluster. By star we mean that there's in this cluster there's one single center and there's several satellites. So this center is the most representative document in the current cluster. How could we label our cluster? So remember that in the history collection, each document corresponding to a query. We just use this sender query to label the cluster. And then finally, we just after we learned these aspects, what we did lastly is just to categorize the search result into these different aspects, and then we attain the goal to organize the search result. So in our implementation, we just use a very simple one, is use a central-based method. Basically, for each aspect, we build a term vector, a central term vector, and then we, for each search result, we also build a term vector. We calculate the similarity between this central vector and this search result vector, and then to decide which aspect should we put the result. Okay, here's more information about how could we build the history collection from the logs. In the search logs, we have a lot of sessions. Here, session is a different meaning. In each session, we mean that there's only one query and one query and some kind of clicks on this kind of session. So for every word, for every query, we go back to the search log to see which session contains this query. And then we aggregate all the clicked URLs. For example, for the car rental, we may have a list of URLs that record in the logs, which basically means the user has clicked on U1 and U2. And then we submit this query to the original search engine, and to check, get a list of the URLs, get a list of snippets, and then we check which URL has been clicked. For example, this two may have been clicked. And then we simply aggregate all the snippets of these two URLs and put them as a pseudo document for this query. And we did the similar procedure for every query. So in this collection, and to build this kind of history collection. And in this history collection, you can see that there's one query here, and there is a corresponding pseudo document. Okay, here's just more information. Okay, to evaluate our method, we use the search log. So the question we want to answer is whether our log-based method could, whether our method could organize the search result to facilitate the user to find their relevant document more accurately. So to test that, we basically separated the whole log data into two parts. The first part is the first two-thirds of logs based on the time. First two-thirds of the logs to simulate the history, and we build the history collection on this set. And then the last one-third of the log is used to simulate the future queries. And here are some statistics about the history collection. And then we further separated the future collection into two sets for the validation and testing. So here is more details about what the test cases what we use. A test case is just those, one session will be a test case. So finally, we got 170 test cases in both of the test sets. To evaluate different algorithms, we just use the clicked URLs to approximate the relevant documents. Since we do not have the user judge the relevant document for each query, we just use this clicked URLs to approximate the answer. Okay, here's the experiment design. We basically compare with the other two methods. The first method is the original search engine ranking. The other is a cluster-based method solely based on the content. The third one is our method. We name it as log-based method. For the evaluation metric, we use the precision 5 to evaluate a different method. And we also use the mean reciprocal rank as the other measure. So for the clusters, we only evaluate this kind of the cluster which has the largest number of the relevant documents. This is a similar method adopted by the previous work. Okay, here's the overall comparison. Let me draw your attention to this part. this part is basically to compare our method and the the baseline method our method and the cluster-based method. So we can see that this we do improve the result a lot. And to compare the log-based method and cluster-based method, we do some statistical test. So this shows our improvement is statistically significant. Okay. So the other question is we would like this kind of collaborative research could help the difficult topics. We do more analysis to see whether our technique could improve on those kind of difficult topics. To test this, we partition the queries into 4 bins. So each bin represents a difficult level of queries. So to do this, we just for every query we just calculate this mean average precision, and then order this query one by one. So in an increased list. So the first bin means the most difficult queries, and the last bin means the most easiest queries. And for each bin we count, so whether our method could improve over the baseline method, and count how many queries we improved, how many queries we decreased. So this is the result. You can see that in the first bin we improved most of the queries, but in the last bin we decreased most of the queries. So this means that we do help our method do help those quite difficult queries. Okay, here's more result about labeling comparison. For the cluster-based method, it has two rely on the content to label each cluster or each aspect. So here is some kind of the most frequent keywords in each cluster, and here's the queries where the cluster label generated from our queries. It can be seen that our method could output the cluster label more readable or more informative from a user's perspective. Okay, here's a summary about this work. So we propose to organize the search result in a user-oriented way. We discover some interesting aspect given a query, and then we categorize this result into this aspect. And then another thing is we label each aspect by the past query words. So our method could be more helpful for the ambiguous and the difficult queries. And in the future, we want to do develop more sophisticated method. The current method is very simple. And we also want to study the user interaction and feedback with this kind of cluster interface. Okay, so here's the first result. The second result is about how could we utilize the search logs to reformulate the query. This work is in submission. So for the query formulation, we want to study how could we help a user to formulate their query. Remember that once you have some information need in your mind, you will translate your information need to some keywords and input the keyword into a search box to get some result. Sometimes your query is not very effective, and you want to know how could I reformulate this query to get a better result. So in these cases, so what we could do to help the user. So let's take a look at why a query is ineffective. We see 2 reasons. One reason is about the vocabulary mismatch. Here I give you an example. So if you want to wash your car, a better query may be a car wash. But sometimes if you are not expert in this field, you may input the auto wash as a query. But this query is not as effective as car wash. So in this case, we might suggest that the car wash to replace the auto wash. The second reason is about the lack of discriminations. So some queries are just underspecified. So for example, for the auto coat, this kind of query, the result could be a mix of the insurance auto coat or the sealed codes. So in these cases, so the query is just underspecified. So you cannot find a very relevant result. So in these cases, it's good to suggest the user to add some words to specify their information need more accurately. So these are 2 reasons why a query is ineffective. Next, I'm going to show how could we utilize the query logs to help the query reformulation and to tackle these two problems. The first one is to tackle the vocabulary mismatch. So remember that For the vocabulary mismatch, the goal is that we want to do some query rewarding. So give a query, we want to, if your query is not effective, maybe one of the words in your query is not as popular, it's not appropriate. So we want to replace such kind of word by the other one, more appropriate one. So to attain this goal, we define a context-sensitive term substitution pattern. Here is the expression of this pattern. So this means that give a certain context, the left context, the right context, word W prime is more appropriate than word W. For example, for the context of wash, a car wash is more better than the auto wash. So this kind of pattern could facilitate us to do more effective query rewarding. So to discover this patterns, here's a procedure. Here's what we do. The first step is that we identify some close synonyms based on a translation model learned from the logs. For example, the auto and the car. We could from the log we could get this kind of information. Car and auto are kind of close synonyms, and we also do some heuristic to polish this result. The second is that to judge which one is more popular. For example, we could go back to the query logs to see, okay, the car wash is more popular than auto wash, so it might be better to use the car wash instead of the auto wash. Okay, so this is a procedure to mine this patterns from the logs. So after we have this kind of pattern, the query rewarding is very direct. The query is, for example, this query has n words, and we want to substitute this W as the other word. So we treat this as left context, this as right context, and then to use the context-sensitive pattern to find a word S to replace this W. Okay, this is the first problem. The other problem is to enhance the discriminations. To facilitate this goal, we define a term refinement pattern. This pattern basically means that given word W in a query, so what are the other words which co-occur with this word very frequently? So for example, give a word auto in a query, we want to find those words. This ensures the seals are the most frequent words which co-occur with auto very frequently. So the procedure is very simple. We just identify the top keywords which co-occur with the current words W most frequently. And after we have this pattern, we can do the query refinement. This query refinement is basically to add words to the original words to enhance its discriminations. So this R word could be chosen which co-occur very frequently with all these query words. So this is the query refinement to enhance the discrimination. Here is just some sample result about query rewarding. The first is the original query. The other is a new query. We can see that the first maps quest is not as appropriate as a map quest. The second one, Sam's Clubs, is not as appropriate as the Sam's Club. It's some kind of plural and the singular format. So this one, you can see that this query is not effective at this one. It's better to recommend this word once the user input this word as the initial query. Okay, here's the result, some sample result about the query refinement. All these words are listed based on the likelihood which occur most likely with the query words. For example, for the MySpace glitter, it's better to enhance the discrimination of this query by adding some graphics, adding some comments, this kind of words into the query. Okay, here's the summary about this work. So we mine some knowledge from the query click logs to see what is the effective query formulations. And then we develop an algorithm to specify, to mine two types of contexts. And these two types of patterns, these two patterns is used, first is used to do the query rewarding. The second one is to do the query refinement. So for the future work, we want to better measurement of the effectiveness of pattern, and we also want to integrate some dictionary to find better close synonyms. Okay, so let me use this slide to finish my presentation. So this is the request to the asset. The good thing is that okay, we have this kind of data. We can study more the personalized search and the collaborative search. And we can learn user preference and query reformulation knowledge from this logs to facilitate the user when the user has some difficult topic. The bad thing is that we do not have relevance judgment for different topics. So in our work, we use a click to approximate, but the click are not always reliable. So wanted is that we want similar data. We want to, the first is that we want some kind of relevance judgment for some particular topics such that we could do more solid evaluation about this collaborative search. The second thing is that we want to, the log, we should spend a longer time such that we could study some trends there. What's the periodical trends or what's the worst trend there. Okay, thank you. Question?
Nicola Archak, NYU. How are you going to deal with cold start problem? For example, we have a new user who had no queries or a poor set of queries, or a user who wants to search for some new information. For example, usually I search for cars, but now I want to search for Jaguar, who is an animal.
Okay. So this, if the
I
code
understand
start,
that your algorithm is not targeted to deal with such problem, but is it possible to somehow combine it with traditional search results?
what do you mean by the combined search?
No, for example, your ranking, is it possible to combine it in a natural way with ranking produced by traditional MSN search engine?
I'm not clear. I mean, let me
Okay.
answer your code start problem. I think the code start problem is a very big problem for the personalized. If the user does not have any query history, it's very hard for you to do this kind of personalized. But for the collaborative, we could utilize some kind of knowledge from the other user to help you. Once you input some query, we could get some information from other users and use their information to help you to improve your search result. Does it answer your question?
Okay, thank you.
Okay.